The National Electrical Code (NEC) addresses the use of International Electrotechnical Commission (IEC) Zone 1 telephones in Class 1, Division 1 hazardous locations in Section 505. 10. B tier. This section is crucial for ensuring safety and compliance when installing communication equipment in environments where flammable gases or vapors may be present. Understanding this section requires a grasp of the NEC classification system for hazardous locations and how it relates to the IEC Zone system. The NEC divides hazardous locations into classes, divisions, and groups, based on the type of hazardous material present and the likelihood of its presence. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantity sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where ignitable concentrations of flammable gases or vapors exist continuously, intermittently, or periodically under normal operating conditions, or where ignitable concentrations may exist frequently because of repair or maintenance operations or because of leakage, or where equipment breakdown or faulty operation might release ignitable concentrations of flammable gases or vapors, and might also cause simultaneous failure of electrical equipment. The IEC, on the other hand, uses a zone system to classify hazardous areas. Zone 0 is an area in which an explosive gas atmosphere is present continuously or for long periods. Zone 1 is an area in which an explosive gas atmosphere is likely to occur in normal operation occasionally. Zone 2 is an area in which an explosive gas atmosphere is not likely to occur in normal operation, but, if it does occur, will exist for a short period only. Given these classifications, it's important to understand how equipment certified for IEC Zone 1 can be used safely in a Class 1, Division 1 location. Section 505. 10. B. 2 of the NEC provides the guidelines for this. This section essentially allows equipment listed and marked for Zone 1 to be installed in Division 1 locations, provided that the equipment meets certain additional requirements. Firstly, the equipment must be suitable for the specific hazardous gas or vapor that is present. This is determined by the gas group designation of the equipment and the hazardous material. The NEC specifies different gas groups, such as Group A, Group B, Group C, and Group D, each representing a different range of flammable gases and vapors. Secondly, the equipment must be installed in accordance with the manufacturer's instructions and any applicable NEC requirements. This includes proper wiring, grounding, and bonding to prevent the accumulation of static electricity or the occurrence of electrical faults. Thirdly, the equipment must be maintained in good working order. Regular inspections and maintenance are essential to ensure that the equipment continues to meet the requirements for use in a hazardous location. It's also crucial to ensure that any repairs or modifications are performed by qualified personnel who are familiar with the NEC and the requirements for hazardous locations. The allowance for IEC Zone 1 equipment in Class 1, Division 1 areas is based on the principle of equivalent safety. The NEC recognizes that equipment certified to IEC standards can provide a level of safety that is equivalent to or greater than that provided by equipment certified to North American standards. However, it's essential to verify that the IEC equipment meets all of the applicable NEC requirements before it is installed. There are several factors to consider when selecting and installing IEC Zone 1 telephones in Class 1, Division 1 locations. Firstly, the telephone must be certified by a recognized testing laboratory, such as Underwriters Laboratories, UL, or Canadian Standards Association, CSA, to meet the applicable IEC standards. The certification mark indicates that the telephone has been tested and found to comply with the relevant safety requirements. Secondly, the telephone must be suitable for the specific hazardous gas or vapor that is present. The telephone's gas group designation must match the gas group of the hazardous material. If the telephone is not suitable for the specific hazardous material, it should not be used in the location. Thirdly, the telephone must be installed in accordance with the manufacturer's instructions and any applicable NEC requirements. This includes proper wiring, grounding, and bonding. It's also important to ensure that the telephone is protected from physical damage. Fourthly, the telephone must be maintained in good working order. Regular inspections and maintenance are essential to ensure that the telephone continues to meet the requirements for use in a hazardous location. Any repairs or modifications should be performed by qualified personnel. In addition to these general requirements, there may be specific requirements for telephones installed in Class 1, Division 1 locations. For example, the NEC may require that the telephone be intrinsically safe, meaning that it is incapable of releasing sufficient electrical or thermal energy under normal or abnormal conditions to cause ignition of a specific hazardous atmospheric mixture in its most easily ignited concentration. Intrinsically safe telephones are designed to limit the amount of energy that can be released into the hazardous atmosphere. This is achieved by using special circuit designs and components that limit the voltage and current levels. The NEC may also require that the telephone be explosion-proof, meaning that it is enclosed in a housing that is capable of withstanding an internal explosion of specified flammable gas or vapor without igniting the surrounding atmosphere. Explosion-proof telephones are designed to contain any explosion that may occur inside the housing. This is achieved by using a robust housing construction and special seals to prevent the escape of flammable gases or vapors. When installing IEC Zone 1 telephones in Class 1, Division 1 locations, it's important to consult with a qualified electrical engineer or other expert who is familiar with the NEC and the requirements for hazardous locations. The engineer or expert can help to ensure that the telephone is properly selected, installed, and maintained. It is also important to remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the requirements of the NEC to provide an adequate level of safety. For example, it may be necessary to use additional protective measures, such as gas detectors or ventilation systems, to reduce the risk of explosion. Furthermore, consider the specific application and environment in which the telephone will be used. Factors such as temperature, humidity, and the presence of corrosive materials can affect the performance and reliability of the telephone. Choose a telephone that is designed to withstand the specific conditions in which it will be used. Also, ensure that the telephone is compatible with the existing communication system. Consider factors such as the type of signaling, the impedance matching, and the power requirements. It's also crucial to have a clear understanding of the emergency procedures for the facility. Ensure that the telephone system is integrated with the emergency response plan and that personnel are trained on how to use the telephone to report emergencies. Regular training and drills can help to ensure that personnel are prepared to respond effectively in the event of an emergency. Keep accurate records of all inspections, maintenance, and repairs performed on the telephone system. These records can be used to track the performance of the system and to identify any potential problems. They can also be used to demonstrate compliance with the NEC and other applicable regulations. In addition to the NEC, there may be other applicable regulations or standards that must be followed. For example, the Occupational Safety and Health Administration (OSHA) may have requirements for the use of telephones in hazardous locations. It's important to be aware of all applicable regulations and standards and to ensure that the telephone system complies with them. The NEC Section 505.10b(2) is not the only relevant section when considering communication devices in hazardous locations. Other sections of the NEC provide guidance on wiring methods, grounding, bonding, and overcurrent protection for electrical equipment installed in these areas. For example, Article 500 provides general requirements for Class 1, Division 1 and Division 2 locations, while Article 501 provides specific requirements for Class 1 locations. Article 502 covers Class 2 locations where combustible dust is present, and Article 503 addresses Class 3 locations where ignitable fibers or flyings are present. When working in hazardous locations, it is imperative to use appropriate tools and equipment that are designed to minimize the risk of ignition. Non-sparking tools, for instance, are often required to prevent the creation of sparks that could ignite flammable gases or vapors. Additionally, all electrical equipment used in these areas must be properly grounded and bonded to prevent the buildup of static electricity. Another important consideration is the training and qualification of personnel who work in hazardous locations. Individuals working in these areas should receive comprehensive training on the hazards associated with flammable gases, vapors, or dusts, as well as the proper procedures for working safely. This training should include instruction on the use of personal protective equipment such as respirators and flame-resistant clothing. Regular refresher training is also essential to ensure that personnel stay up to date on the latest safety practices. Furthermore, consider the potential for changes in the hazardous environment over time. Factors such as changes in production processes, the introduction of new chemicals, or modifications to ventilation systems can affect the classification of a hazardous location. It is important to periodically re-evaluate the hazardous area classification to ensure that it is still accurate and that the electrical equipment installed in the area is still suitable. The NEC also addresses the use of intrinsically safe systems in hazardous locations. An intrinsically safe system is one in which all of the electrical circuits are incapable of releasing sufficient electrical or thermal energy under normal or abnormal conditions to cause ignition of a specific hazardous atmospheric mixture in its most easily ignited concentration. Intrinsically safe systems are often used in hazardous locations because they provide a high level of safety. The NEC contains detailed requirements for the design, installation, and maintenance of intrinsically safe systems. These requirements cover aspects such as the selection of intrinsically safe equipment, the wiring methods used to connect the equipment, and the grounding and bonding of the system. When using intrinsically safe systems, it is important to follow the manufacturer's instructions and to ensure that all components of the system are compatible with each other. Any modifications or repairs to an intrinsically safe system should be performed by qualified personnel who are familiar with the NEC requirements for intrinsically safe systems. In addition to intrinsically safe systems, the NEC also recognizes other methods of protection for electrical equipment in hazardous locations, such as explosion-proof enclosures, purged and pressurized enclosures, and oil-filled enclosures. Each of these methods of protection has its own advantages and disadvantages, and the selection of the appropriate method will depend on the specific application and the characteristics of the hazardous environment. Explosion-proof enclosures are designed to contain any explosion that may occur inside the enclosure, preventing it from igniting the surrounding atmosphere. Purged and pressurized enclosures use a positive pressure of clean air or inert gas to prevent flammable gases or vapors from entering the enclosure. Oil-filled enclosures immerse electrical components in oil to prevent them from coming into contact with the hazardous atmosphere. When selecting a method of protection for electrical equipment in a hazardous location, it is important to consider factors such as the cost, the ease of installation and maintenance, and the level of protection provided. It is also important to ensure that the equipment is certified by a recognized testing laboratory to meet the applicable NEC requirements. The NEC is constantly evolving to keep pace with changes in technology and industry practices. It is important to stay up to date on the latest revisions to the NEC to ensure that electrical installations in hazardous locations are safe and compliant. The NEC is typically updated every 3 years, and each new edition incorporates changes and additions to address new hazards and technologies. Staying informed about these changes can help to prevent accidents and ensure that electrical systems are designed and installed in accordance with the latest safety standards. Another important aspect of electrical safety in hazardous locations is the proper labeling and marking of equipment and wiring. The NEC requires that all equipment and wiring used in hazardous locations be clearly labeled with the appropriate class, division, and group designation. This labeling helps to ensure that personnel working in these areas are aware of the hazards present and can take appropriate precautions. The labeling should be durable and easy to read, and it should be maintained in good condition. Any damaged or missing label should be replaced promptly. In addition to the class, division, and group designation, the labeling may also include other information such as the equipment's temperature code and the manufacturer's name and model number. This information can be helpful in selecting the appropriate equipment for a particular application and in ensuring that the equipment is properly installed and maintained. Finally, remember that electrical safety in hazardous locations is a shared responsibility. Everyone who works in or around these areas has a role to play in preventing accidents and ensuring that electrical systems are safe and compliant. By following the requirements of the NEC, staying up to date on the latest safety practices, and working together to identify and address potential hazards, it is possible to create a safe and productive work environment in even the most challenging hazardous locations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or other expert before making any decisions about electrical installations in hazardous locations. It is also important to comply with all applicable codes, standards, and regulations. Section 505. 10. B2 of the NEC serves as a crucial reference point for safely integrating IEC Zone 1 telephones into Class 1, Division 1 hazardous environments, underlining the code's adaptability and commitment to safety across different international standards.